All right, so we are going to talk about solving systems by graphing. There's a couple of steps to solve this. Okay, and this is the first of three methods we're going to use to solve a systems of equation. So let's start by writing out the steps. So the first step is to get your equations into slope-intercept form. So get both equations. Get both equations in slope-intercept form, which, if you remember, is that y equals mx plus b. So we want y alone. The first couple that we do together is going to be in slope-intercept form, so you won't have to do that. But once we get through a day or two of practice, then they'll start not being in slope-intercept form. So, yeah, so you're going to have to make sure that they're both in slope-intercept form. And then you graph both lines. So we're graphing both lines on the same coordinate plane. And then you need to find the point of intersection, which what I mean by that is where they both cross, okay? So the answer to a systems of equations will be an ordered pair. So remember x comma y, and that's the form that you have to put it in. You have to put it in parentheses, you have to put the comma, you have to put the x first, okay, because that's the answer. Okay. You may be thinking, I don't want to put a billion points on this graph. I just want to do a couple, right? So that's not really going to fly with some of these because you won't be able to tell where it is. So you want to put as many as possible. And an intersection point, remember, is where they cross. Okay, so you're probably going to want to get a ruler out. So I would pause the video right now and get out a ruler. Okay, so hopefully you paused and went and grabbed a ruler, or you're using the ruler up here. So there's a ruler right here that'll help you draw a line. So that's what I'm going to use, but I'm not going to use it right this second. Okay, so okay, so we have to graph these lines, right? So just a quick review of graphing lines. We want to start at our y-intercept, which is +3, and then we want to move our slope, which if it's 1, it's really 1 over 1. Since it's positive, I go up and to the right. So I'm going to go up 1 over 1, up 1 over 1, and I'm going to keep on going forever and ever and ever. Once I can't go up, then I go down and to the left forever and ever and ever. And I'm going to want to put all of these points because I don't know where they're going to cross at, right? So now I'm going to use my ruler tool. And I'm not really sure how to use it, if we're being honest. How do you rotate this guy? Okay, now I'm just wasting time, which was not helpful. Okay. Oop. Oh, now I'm erasing. Connect your dots. You're going to want to be precise so you can see where they cross, okay? And then our other line, right? We have our +3. So it starts here as well. And now it's a -1. So that means we go up and to the left. So I'm not going to do, no, I am going to do all the points. Just so I get a nice, clear understanding of where these lines are. Connect all your points. Okay. And remember, we want to find where they cross at, right? So the point of intersection is right here, right? Is that point, that starting point. So what is that point? Well, x is 0 and y is 3. So then my point of intersection is 0, 3. Okay? I'm going to do one more with you. Okay? So we're going to start at -6 for this first one. So I'm going to start down here. My slope is 3, which is really 3/1, and it's positive, so I go up and to the right. So I go up 3/1, 3/1, up 3/1. I'm going to keep on going until I can't, and then I connect those dots. See, this is why I'm saying use a ruler, because it's not always going to be easy to draw that straight line, okay? And the next one is here, where we're going to start up at +6. Remember, there's an implied 1 here, so it's really -1/1. Since it's negative, I go up and to the left. So up and to the left 1, and these feel never ending because you have so many points. Okay, and then we have to find our point of intersection. Okay, so if you see that they do not line up, right? So that means we did something wrong. So you need to be careful with this graph because where the negative is, like where that 6 was, doesn't actually match where it is. So that was Miss Myers' oof. So this is really -1, -2, -3, -4, -5. So up 1 is -6. I did it down here, so that's why everything was off, because I did it under the -6. So with these graphs, you'll have to go up, and then it's up 3/1. So just be careful that you don't make that mistake that I just did. Up 3/1, and now we have our intersection point. Okay, so if they don't line up, then you're going to want to check if you did something wrong like I just did, okay? So our point of intersection is right here at x is 3 and y is 3. So then my ordered pair is 3, 3. Okay, so there, of course, are special circumstances. Sometimes you have lines that are the same. So if you have lines that are the same, our answer is going to be infinite solutions. So when you graph them, they're going to have the same exact line. If the lines never cross, what does that mean? Well, if the lines never cross, that means it's no solutions. No solution. Okay. So the first thing you need to do, remember, is to get both of these in the y-intercept form. You need to get both this one and this one into y-intercept form. So you have some room to solve it. So we have 5x plus 3y equals 9, and 2x minus 3y equals 12. And we want to get y alone for both of these, right? So we're going to subtract 5x on both sides. That leaves me with 3y equals -5x plus 9. And then again, we want to get y alone, so we divide everything by a +3. And we get y equals -5/3. Leave it as a fraction plus 3. Right? So now I can graph this. So I go to +3, and because it's negative, I go up and to the left. Go up 5, 1, 2, 3, 4, 5 over 1, 2, 3. I can't go any further, so I'm going to do the opposite. I'm going to go down 5 and over 3. Again, watch where your negatives are. 1, 2, 3, 4, 5 over 3. And that's all I can get in. So I'm going to connect these points. Okay. So now we need to solve for the other one. Again, trying to get that y alone. So -2x on each side. Now it's not just the 3y. It's a -3y. So don't lose that negative sign. And we have -2x minus 12 on that side. Again, divide everything by -3. So you're going to get y equals, when we do a negative divided by a negative, it gives us a positive, right? So positive 2/3 x. And then negative divided by negative is a positive So it'd be plus 4. Okay. Now we're going to graph this. So we're going to have plus 4. Just kidding. Miss Myers is making so many oops. I'm sorry. This was a positive 12. So that means that this is a minus. I apologize. So watch your signs, unlike Miss Myers. So remember, when we have a negative and we start this, you have to really be careful counting. So 1, 2, 3, 4. It's really above the negative 4. And then because it's a positive slope, we go up and to the right. So go up 2, over 3, up 2, over 3, up 2, over 3. Can't go up any further. Down 2, over 3, down 2, over 3, down 2, over 3. So now this is our line. Where do they intersect? Well, they intersect right here at x is 3 and y is negative 2. So our answer is 3 comma negative 2. Okay, I want you to try the next two. Just kidding. We'll do one more and then I'll have you do example 5 on your own. Okay, so one of them is already in slope-intercept form. So we could start by graphing that, right? So let's start by graphing that. We go 1, 2, 3, 4, down. We go up 4 over 3, up 4 over 3, up 4 over 3, and so on. If you can't go up anymore, go down. Okay, so there's our graph. And then we have to get this one alone first. So we have to solve for y on this one. So we're going to subtract 4x on each side. So we don't have just 3y, we have negative 3y equals negative 4x. Don't mess up your sign like I did last time. We divide everything by negative 3 because of the negative 3y. We want y alone. So negative divided by negative is a positive 4/3. This is a minus 4. And what do you notice about this equation and this equation? Well, they're exactly the same, right? So if I were to graph this, I'd go down to 4. I'd go up 4 over 3, up 4 over 3. So it's the same exact line. So if it's the same line, the lines are the same, it's going to have infinite solutions. So that's what I write on here. These are the same line. So they're infinite solutions. Okay, so infinite solutions. All right, so I want you to try example 5 on your own. Okay. Yes. So try example 5 on your own, and we'll talk about that next time we see each other in class, okay?